Hi everybody, it's Professor Mitchell, and today we're talking about section 4.4, trigonometric functions of any angle. So I mentioned at the beginning of 4.2 that there are three different ways to define these trigonometric functions. First we had in terms of the unit circle, and then we had in terms of a right triangle. Okay, so now we can extend that to any angle. Right triangle only works for acute angles, right? Angles between 0 and 90 degrees. Okay, so our objectives in this section, first use this definition, and then talk about the signs SIGN of the trig functions. I always, whenever I say sine SIGN or sine SINE from now on, I'll probably spell it in case it's not clear from the context. We're going to talk about reference angles, and that's about it. So here's how you define the trigonometric functions in terms of any angle. Notice that if this angle happens to be an acute angle, then this is exactly the same definition we had for a right triangle. So you have this point x comma y, and you draw a line from the origin through x comma y. X comma y could be in any quadrant. It does not have to be in quadrant 1. And then the way that you define your 6 trigonometric functions of this angle, the sine of theta is y over r. Notice that because this picture is in quadrant 1, y is the opposite and r is the hypotenuse. That makes this a little easier to remember. Okay. The cosine of theta is x over r. X is the adjacent, r is the hypotenuse. Tangent of theta is y over x. That definition is exactly the same as it was for unit circle. Okay. And then the cosecant, the secant, and the cotangent are still the reciprocals of the sine, the cosine, and the tangent. Okay. Now, let me just point out that most of the time, this distance r will not be given. They will not come right out and tell you what this distance is, and so you have to figure it out using the Pythagorean theorem. Okay. Okay, so example of evaluating trig functions at any angle. Suppose that 1, -3 is a point on the terminal side of theta. That is enough information to find each of the 6 trigonometric functions of theta. So the first thing I have to do, remember that the 6 trigonometric functions are defined in terms of x, y, and r. All right? So I have x. Here's x. And I have y. But what I don't have is r. Okay, so the very first thing I have to do is figure out r. You use the Pythagorean theorem to find r. Okay. So there's r. You do the square root of x squared plus y squared. 1 squared plus the square of -3 is 1 plus 9. So r is the square root of 10 by the Pythagorean theorem. So now I have x. I have y, and I have r. So now I can write down all 6 of these using the definition. So, and I do think, you know, SOHCAHTOA does help to remember this. It's a lot easier to remember than y over r, x over r. But sine theta is y over r. So that's going to be -3 over the square root of 10. And if you're doing this for a person or a program that cares about rationalized denominators, then you're going to want to rationalize the denominator. Multiply the top and the bottom by the square root of 10. So you get -3 square root of 10 over 10. Make sure you don't forget that negative sign. And the cosine of theta will be x over r, which is 1 over the square root of 10, and again, rationalize the denominator. All right, and then the tangent of theta is y over x, just like in the unit circle definition. That comes out to -3. The cosecant of theta is r over y. It's the reciprocal of sine, which is y over r. So that one comes out to -√10/3. The secant of theta is r over x, which just comes out to √10. And finally, the cotangent of theta is x over y, which just comes out to -1/3.